Did you know that material scientists are exploring ways to extract oxygen and metals from lunar dust on the moon's surface? Stay tuned for more. Hey everyone, and welcome to XSTEM All Access. I am Maynard Okereke, also known as the Hip Hop M.D, and I'm excited to be part of this series showcasing some of the coolest minds in STEM. As your guest host for this episode, I am excited to chat with Dr. Jamesa Stokes. Jamesa is a material research engineer at NASA Glenn Research Center, where she works to understand how advanced materials behave in extreme environments like high altitudes and space. Jamesa, welcome, and thank you for joining us today.
Thank you, Maynard. I'm super excited to be here today.
Oh, I am excited as well. So let's jump right in. Jamesa, when people think of NASA, the first thing that probably comes to mind is usually space travel and exploration. Can you tell us about the materials you're developing at NASA and how they impact us here on Earth?
I work on materials for both aeronautics and space. The main example I like to give is that I develop what's called thermal and environmental barrier coatings for airplane engine parts. It's important to protect airplane engine parts. You know, these are the commercial airplanes that we fly every day. Because if we can protect those components in the engine, we can let the engine run hotter, which helps improve fuel efficiency as well as reduce harmful emission products. So decades ago, the first coatings for these airplane engine parts were actually invented right here at NASA Glenn in Cleveland. And within this current project that I'm working on, I'm looking at new ways to develop better coatings against interactions with dust and volcanic ash that's ingested into the engine while we fly. I think it was about a decade ago, there were these volcanic eruptions over Iceland, which basically grounded all the flights over Europe. That's because dust in engines is very bad. It can damage your coatings, but also can clog your cooling channels and basically ruin the efficiency of your engine. And so I'm also working to figure out ways to help mitigate those damaging effects.
Wow. So even though you work for NASA, your contributions to aeronautics also help improve the commercial airplanes that we fly on every day. That is absolutely amazing. I'm curious now, though, how do you test materials to withstand the extreme environment of high altitudes and space from right here on Earth?
So when we say extreme environments, what we mean is that could be an environment where you're thinking about very hot temperatures, very cold temperatures, differences in pressures, and even very corrosive or oxidative environments. So the way that we test really depends on what the application is for. I'm primarily dealing with materials that are going to go into high temperature applications. So I work on materials for airplane engine parts, but then also I work on materials for thermal protection systems for atmospheric reentry vehicles. So some of the tests that we could do, for example, we have burner rig facilities where we have these amazing torches that we can light. So exposing materials to super high temperatures really quickly, but we can test them on a more fundamental level. For example, characterizing their properties like thermal expansion or even their mechanical properties as a function of temperature. So it really depends, but the nice thing is here that we have a bunch of cool tools to use to evaluate.
How amazing that we have the tools to test something as extreme as re entry into Earth's atmosphere. It's completely mind blowing. Just to give you some perspective as to how hot that is, spacecrafts are designed to withstand temperatures up to 5,000 degrees Fahrenheit at reentry due to the compression of gas and air particles against its surface. So we're talking scorching hot. And while we're on the topic of harsh environments, it doesn't get much more exciting than the Artemis mission to return humans back to the moon. How is work by material scientists making this historic mission even possible?
In my case, I'm working on the materials considerations for converting lunar dust to metals and oxygen on the lunar surface. There are a few processes that people are developing to do that called in situ resource utilization. But in particular, I am trying to develop new materials for these processes that can be used at 1600 degrees Celsius, which is about 3000 degrees Fahrenheit, so super hot. In addition to trying to make things out of lunar dust, we are also working on dust mitigation techniques for structures on the moon. It was the 50th anniversary of Apollo 13 And one of the things the Apollo missions taught us is that one of the greatest challenges in, living and working on the lunar surface is the removal of very fine, highly charged lunar dust particles from surfaces, which can include helmet visors, the spacesuits. Lunar dust is very abrasive. It sticks to everything. It's a very annoying problem to deal with. So we're also looking for solutions for that as well.
Okay, wait a minute. Did you just say that you're exploring ways to make oxygen and metals from lunar dust on the moon's surface? I feel like we're in the middle of an actual Star Trek episode. It's crazy. Your work as a material scientist is literally supporting the possibility of humans having a long term presence on the moon. How cool is that? Jamesa, word on the street is that you're also an artist and actually started as a studio art major in college. How do you use your artistic side as a materials research engineer? And do you find you're able to incorporate your artistic talents into your work?
I think it's so important as scientists and engineers to have a creative hobby, because creativity really allows you to think outside the box and come up with innovative ideas to solutions and problems. In terms of my work, I find it most useful when I'm making images and figures for presentations or papers that I write. I really like putting together the data and finding the most aesthetically pleasing way to present it while also getting my main points across in what I observe from that data. So that's how I really use my creativity day to day in my job.
I couldn't agree more that creativity is critical to science and engineering innovation. Now, contrary to what people may believe, science is one of the most creative fields out there. We wouldn't have literally any of the innovations we have today without a little creativity. And I try to showcase that on my hip hop science platform by using entertainment as a tool to educate. It's simply one of the best ways to learn and understand that science plays a role in your everyday life. So, Jamisa, I would like to know, what do you envision or hope will be the next big discovery in materials science?
I think the next big discovery in material science that I would like to see is like the improved processing and manufacturing of ceramic materials. We've come a long way, especially at Glenn. We have a lot of expertise in so what people used to be called 3D printing when it first was developed. We were mostly printing with plastics, but now that we've gotten really good at printing metals, we call it uh, a general encompassing term called additive manufacturing. And then we're slowly starting to get into a better way of doing that for ceramics. The problem with ceramics is that typically they have to be processed at really high temperatures in order to develop a part that's mostly defect free and can perform as well as traditionally made ceramic parts. And so I think if we can continue to develop better ways to additively manufacture ceramics, that would be awesome.
Many of us think of plastics when we think of 3D printing, but the ability to use this technology with other materials like metals or ceramics is a game changer for technological advances in manufacturing. 3D printing, which is also known as additive manufacturing, is a disruptive technology across many industries. So let's actually take a closer look at how this advancing technology impacts our lives. Wow. Airplane and auto parts, home building, and even advances in medicine. And that's not all. Here are some other examples of how 3D printing is transforming our world. Jamesa, working at NASA is a dream job for many of us out there, but what other industries could a material science professional work in?
The nice thing about material science and engineering is that it's very interdisciplinary. So for example, my path led me into working on materials for aeronautics and aerospace. But I have friends from graduate school who work on biomaterials for their research. Currently, I have friends who work for different electronic companies making semiconductor materials. We even had someone in grad school during one meeting, an alumni came back and talked to us about the fact that he worked for a shampoo company. So really anything you can think of, materials are needed to make any application better.
It's hard to imagine an industry or product that isn't enhanced by contributions of material scientists. Jamesa, I want you to know you've likely ignited an interest in material science among the students watching here today, and you earned a PhD in the field. But I'm curious, are there other jobs in material science that a current high school student could start working towards, or someone with an associate's or bachelor's degree, or even certifications?
Absolutely. So I'll preface this by saying that I wanted to do my PhD because a PhD is a really good foundation in teaching you how to conduct research, but it's definitely not necessary in order to do a job in material science and engineering. My current boss, he does not have his PhD. He started here at NASA as a technician and a test engineer. So those are the type of jobs that you can definitely get. Even manufacturing careers, for example, those are awesome jobs that you can get that you don't need a PhD for, but some level or knowledge of material science may be needed. So I think there's plenty of opportunities depending on the path that you want to take your career. If research is something that you're super interested in, typically people do have a PhD in order to conduct research, and typically that's what jobs ask for, but that's definitely not across the board. It just really depends on what where your passions lie and where you want to take your future career.
Students, I encourage you to check out the career resource page to further explore material science and the many career applications that it has to offer. Jamesa, I want to thank you so much for chatting with me today about your work with materials in extreme environments and how your contributions not only protect astronauts, but also all of us who travel on commercial aircrafts.
Thank you, Maynard. It was awesome to be here. And thank you so much to all the students who tuned in. I really hope this motivated you to learn more about material science and engineering, why it's so important to our day-to-day lives, and maybe even encourages you to study material science and engineering in the future.
Amazing. I know I'm definitely inspired to learn more. So make sure you subscribe to the YouTube channel in the description below and follow us on social media to get updates about new episodes. You do not want to miss any of them. Plus, you'll get access to fun weekly content for students and teachers. And don't forget to check out the full library of episodes available on demand right here. Each one has an NGSS-aligned lesson plan for teachers to use in the classroom. And each lesson also includes a career connection component so your students can explore real world careers associated with this topic. I had an absolute blast as always being your host today, and you can keep up with my own crazy STEM adventures right here. I'll catch you next time for more XSTEM All Access episodes where we'll meet more of the coolest minds in STEM. See you next time.